Dear students, today we are going to prove what? What is our topic today? That is basic proportionality theorem or Thales theorem. The history of Thales theorem or basic proportionality theorem, we have discussed it in the previous lecture. Today we are going to prove this basic proportionality theorem or Thales theorem. Let's see what is the statement or what this theorem states. First, I will show you with the help of a figure. It states that this theorem states that if a line is drawn parallel to one side of a triangle to intersect the two sides at two distinct points. Say this is our triangle ABC and this line intersects these two sides at distinct points D and E respectively. Then what the theorem says, it says that this line will divide these two sides in the same ratio. That means what we have to prove? We have to prove AD over DB is equal to AE over EC. This is the statement of the theorem. Now let's write what it states. This theorem states that if a line is drawn parallel to one side of a triangle to intersect the other two sides at distinct points comma, then this line it divides the two sides in the same ratio. That is, it divides these two sides in the same ratio. That is what we have to prove. Now let's see its proof of this theorem. Before starting the proof, what we will do, this is our triangle ABC. Suppose this is our triangle ABC and a line intersects this AB at D and AE at E. So we have to prove AD over DB is equal to AE over EC. To prove this, what we will do, we will join this BE and DC. We will join these two points, the DAC and EB. Also, what we will do, we will draw EN perpendicular on AB and we will draw DM perpendicular on AC. Now I will write what we will uh, construct, what we will construct for the proof of this theorem. Let ABC be a triangle in which DE DE parallel BC, DE parallel BC. Now to prove that this to prove that AD over DB is equal to AE over EC, what we will do, we join BE, and DC, also we draw this EN perpendicular AB and DM perpendicular AC, Now we have what we have. Now we have what will be the area of triangle ADE. Since we have drawn two perpendiculars EN and DM on its two sides, so we will take these as it is heights. Now we have area of triangle ADE. Is equal to 1/2 of base. When we take this as it is perpendicular, we take AD as base. That is AD cross EN. And again area of triangle ADE is equal to what? 1/2 of, when we take this AE as base, then at that time DM will be the perpendicular, because area of triangle ABC or area of triangle will be equal to 1/2 of base into height. That is why I wrote here I have 1/2 of base into height. Here also 1/2 of base into height. Now let's name this as equation first and this as equation second. Now see this BDE. What will be the area of triangle BDE? See, this EN is also perpendicular on AB. That means BD extended. When this BD gets extended to A, this EN is perpendicular on this side. Therefore, we can write area of triangle BDE is equal to 1/2 of base, that is this BD into perpendicular, that is this EN. Let's name it as equation third. Again, also area of triangle this DCE. What will be the area of triangle DCE? It will be 1/2 of CE. 1/2 of CE into on CE. Which one is the perpendicular? It is DM is perpendicular on this side. It is DM. This will be equation fourth. This will be our equation 4th. Now see, I will divide first by third and second equation by fourth equation. We will see what we will get from it. On dividing equation first by equation third and equation second by equation fourth, we get what we will get. Let's see. Area of triangle ADE. This is equation first. What is equation third? It is area of triangle BDE. And what are the right hand sides of these equations? It is 1/2 of AD cross EN over what is the right hand side of third? It is 1/2 of BD cross EN. And from this, what will we get? Area of triangle ADE over area of triangle BDE will be equal to this, and this will go. EN and EN will be cancelled, and we get AD over BD. Let's name it as equation 5th. Now on dividing second by fourth, what we will get? What is equation second? It is area of triangle ADE over area of triangle, what is fourth? DCE. Triangle DCE. It will be 1/2 of what is it? Is second 1/2 of AE cross DM. And what is the right hand side of fourth? It is 1/2 of CE cross DM. And from this we will get this, and this will be cancelled. This and this will go, and it is AE over CE. This is equation 6th. Now see, equation 5th and equation 6th. We have area of triangle ADE. We have area of triangle ADE also. Now see, area of triangle BDE, this triangle, and area of DCE. Area of triangle BDE, this triangle, and area of triangle DCE, that is this triangle. What is your thought about these two triangles? Yes? Yes, you are right that these two triangles lie on the same base, DE, and between the same parallels DE and BC. DE and BC. What we know about these triangles? Since we know that two triangles on the same base and between the same parallels, since we know that two triangles on the same base and between the same parallels are equal in area, which implies that these two triangles are on the same base and between the same parallels. It implies that area of triangle BDE is equal to area of triangle DCE. Now what we will get from this? Area of triangle BDE is equal to area of triangle DCE. See, here it is area of triangle BDE. It is area of triangle DCE. That means areas of these two triangles are equal. Also the numerators of these two are equal, that means left hand sides of equation 5th and 6th are equal. This implies that their right hand sides will be equal. So what will I write? From, therefore, from fifth and sixth, we get, what we will get from fifth and sixth? We will get from fifth and sixth that area of triangle ADE, area of triangle ADE over area of triangle DCE, this area of triangle ADE over area of triangle DCE is equal to area of triangle ADE over area of triangle BDE. These two will be equal. When these two, that means left hand sides of these two equations will be equal, this gives that, their right hand sides will be equal, that is AD over BD, AD over BD will be equal to AE over EC. AD over BD is equal to AE over EC. That proves the result. That proves the theorem. That proves the theorem. I will once again recap what is given, or what this theorem states. It states that if a line is drawn parallel to one side of a triangle and it divides the other two sides in two distinct points, then this line divides these two sides in the same ratio. So what we took in this triangle, we draw two perpendiculars on AB and AC respectively, and also we joined B and EC. Then we took the area of AD, triangle ADE, with respect to both these perpendiculars, and then we took the area of triangle BDE and triangle DCE. Since these two triangles are on the same base and between the same parallels, on using this fact, we got this result. That was the statement of this theorem. Thank you.